All right, precalc basics XII. That's number 12 for you idiots. I'm gonna work it backwards. All right, find the tangent of the arc cosine of 4 over x. So this is saying find the tangent of an angle whose cosine ratio is 4 over x. You have to learn how to read, but that's what it says. It says find the tangent of an angle whose cosine ratio is equal to 4 over x. So this is something that's very much drawable. Of course, you know cosine is a over h. So if I put my angle here, the adjacent side would be 4 and the hypotenuse would be x. So I'm going to need to do tangent. I'm going to need to know opposite over adjacent. So I'm going to have to figure out this missing leg here, and I'll just call her A. You can call it whatever letter of the alphabet you like. A squared plus 4 squared is x squared. A squared is x squared minus 16. So A is the root of x squared minus 16, which is not x minus 4, okay? It's not. No. Don't do that. It's just root of x squared minus 16. All right, so moving forward, now I can do the tangent ratio. The tangent of this thing would be opposite over adjacent, which is root of x squared minus 16, sitting pretty over 4, which is not something like x squared minus 4. I need to say that this is not the root of x squared minus 4. Don't be that kid. Don't be that kid who creates their own thing that nobody has ever shown them. Because it doesn't work. I've never seen it work. You don't know why? Ask me one day and I'll tell you. All right, so find the center is the circle given by the equation blah, blah, blah. Blah, blah, blah. All right, so I'm going to take that 10 right here. I'm going to cut it in half and get a 5. I'm going to square said 5, and I'm going to get 25. And I'm going to add that to both sides. First, I'm going to add it right here by the x. And I'm also going to add it to the right-hand side for balance purposes. Now I'm going to look at y, and I see a negative 4. I'm going to cut it in half, and I'm going to get negative 2. I'm going to take that negative 2. I'm going to square it and get 4. And I'm going to add that 4 to both sides. And now I'm going to factor. This is an x plus 5 times an x plus 5 plus, this is a y minus a 2 times a y minus a 2, and it equals 22. Now, see the 5? See the negative 2? All right, there's shortcuts to all this stuff. This is x plus 5 quantity squared. This is y minus 2 quantity squared, and this is 22. STD form of a circle is x minus an h squared plus y minus a k squared equal to an r squared. So my center happens when I just change my signs, negative 5, 2. And r squared is equal to 22. So r is root 22. It's not a hard problem. It's really not. And the truth is, there's a whole lot less work than I showed. There is. Unless you're a person that has to do all the work. I don't know. All right, so determine the domain of this thing. First off, you cannot, shall not ever be allowed to divide by 0, so x cannot be 6. Secondly, for the square root of anything, the stuff inside is greater than or equal to 0. So 2x must be greater than or equal to 4. X must be, 8, because I shift over. So x is greater than or equal to 4. But we have kind of a contradiction here. I start at 4 and I move right, but I'm not allowed to be 6. So I move to here and then I jump it. So I'm going to go from 4 to 6, union with 6 to infinity. Easy peasy lemon squeezy. 2 fire lookout stations. This is the one where you have to remember about bearings being formed with a north-south axis Two fire stations are 18 miles apart. Hopefully Bella gets farther than putting the 18. With station B directly east, that would be right of station A. Both stations spot a fire. The bearing from station A is north by 39 degrees east. So we start by going north and then 39 degrees east. The bearing from station B is north by 45 degrees west. So 45, these are actually 45 degrees west of north. There's the angles, all right? There's understood right angles here. The north axis and the east-west axis should be perpendicular to each other. And 90 minus 39 ought to be 51. I feel like it is. So 51 degrees. And 90 minus 45 is 45. And I know there's 180 degrees in triangles, so I do a little math. I'm doing 180, take away 96, I believe, which is going to be 84 degrees. Now I'm going to use the old law of sins, aka law of sines. The sine of some side compares to its opposite side. Sorry, the sine of some angle compares to its opposite side, as the sine of another angle compares to its opposite side. So here's a pair that I am in possession of. I know that the sine of 84 degrees would compare to 18, as the unknown side that I want is called x, as the sine of 51 degrees compares to this unknown length x. And then it cross multiplies. Do that, do that. And then we play the isolation game. We counteract with understood multiplication. So x is 18 sines of 51 sitting pretty over the sine of 84. And not that bad. Triangle ABC, it is known that the measure of angle C is 90 and that the length A to B is 12 and the length B to C is 8. And this one's not a special pattern like it was last week. You're going to have to do a little Pythagorean theorem. A squared plus 8 squared is 12 squared. You ought to know what 8 squared is. And you ought to know what 12 squared is. If you don't, you're kind of stupid. 144 minus 64 is 80. So A is going to be the root of 80, which is the root of 16 times the root of 5, which is 4 roots of 5. All right, cool. Why did I do that? Because why not? Because there's 3 possible right answers. I could have simply done, and I wouldn't be this lazy, but the measure of angle A could be the arc sine of 8/12. By the way, 8 over 12, both those are by 4, of 2/3. Or it could have been the arc cosine of 4 root 5 over 12. Let's think about that, 4 root 5 over 12. Isn't that going to be root 5 over 3? Or it could have been the arc tangent of 8 over 4 root 5, which would be 2 root 5 over 5. Because 8 over 4 is 2 up top, and so forth. So, you know, either one of those two are likely. This one is just too easy. Like, I wouldn't do that. It's just too easy. The radioactive half-life, 15, find the average rate of change for this function. The formula for average rate of change is f of b minus f of a, sitting pretty over b minus a. So b minus a is going to be 5 minus a negative 2. I'm going to do that part real quick. That's 7. And now it's time to figure out the top. So let's find f of b. We're going to have a negative. We plug in a 5 and square it, plus 4x. We have a negative. 5 squared is 25. Oops, I need a 5 there, don't I? Plus 20. So I get negative 5. Notice I'm putting f of b where it goes. And it says minus f of a. F of a happens when you plug in a negative 2. And this is where kids make the mistake. When you square a negative, you get a positive, okay? You get 4, but there's a negative symbol out front. 4 times negative 2 is negative 8. Negative 4 minus 8 is negative 12. So I have a negative 5 minus a negative 12, which happens to end up being 7. I really thought this would be something else other than 1, but no, it's 1. Ta-da! 14. I think about 4 of you got this last time. I could be wrong on that. That might be too optimistic. All you really got to know is the formula for half-life, and then you just plug crap in. If 25% is present now, so this thing was buried eons ago, and this is literally what's left. 25% is what's left. When it was buried, it had 100% of its carbon-14. Let's see here. We have T. We have a half-life of 5715. We're going to divide out the 100. I got that backwards too. I don't know why I did that. There's 25% in the present. No, I don't have that backwards. Forgive me, I'm being a dum-dum. That's right. We're going to divide by 100. And you're going to get like 0.25. So 0.25 equals 1/2 times T raised to the raised to the T over 5,715. And the best technique is probably just L-ing both sides. Could have swore that I just changed colors, but it didn't do it. Let's go ahead and make that 0.5 because I think the creator of your test will do that too. Now you have a property that says the exponent of the logarithm gets shifted to the front of the bus. And your goal here is simply the isolation of that t variable. So one of the easy things you can do is you can multiply both sides by 5715. Gone, gone. And now you would be looking at t times the natural log of 5/10 on the right, and 5,715 natural logs of 2500ths on the right. And the last isolation would simply be to divide by the natural log of 0.5. And that's what the answer would look like. It's not hard. 13, find the difference quotient. Now here's a shortcut to this. Like, you pay attention to how I do this. Like, I know the answer is 10x minus 6 plus 5h. How I do that? How did I do that? Well, that's because there's a pattern to these answers. So I'm kind of tired of grading lots and lots of stuff, so I'm just going to look for the right answer. All right, plain and simple. So Bryce, you're going to love that. But whatever. Figure out how I'm able to do that by just looking at the problem. I'm not doing what I'm about to show you. I'm not. There is a shortcut to the derivatives. So how I do that, I don't know. Anyways, let's do this the long way. So we got to find this piece. We have 5 times an x plus an h times an x plus an h because it was squared, minus 6 times an x plus an h. X plus h times x plus h is x squared plus 2xh plus h squared. We still have to take away this, take away 6x, take away 6h. We have to distribute the 5. 5x squared plus 10xh. Remember that 10x? There she is. Plus 5h squared. Remember that 5h? It's there. All right, then it says take away the original function. When you take away the original function, you need to be wrapping. So you're taking away 5x squared minus 6x. It's inside, it cancels on the outside. And by the way, it's all sitting pretty over an h. You have a 10xh. I'm missing something. This is a 6h, isn't it? You have a 10xh minus a 6h. plus a 5h squared, all sitting pretty over an h. And every one of those pieces has an h. So I'm going to cancel from each piece. I have 10x minus 6 plus 5h. And again, when I look at those things, I'm not doing that algebra in my head. There's a shortcut. Write the equation of the transformation f of x equals x to the fourth that has been vertically reflected. That would make it negative x to the fourth. Shifted 2 units right, that would make it negative x to the fourth. Plus, no, blah, blah. That'd make it negative x minus 2 to the fourth. And then down 4, minus 4. Easy peasy, lemon squeezy. The expression I to the 42nd plus I to the 18th is equivalent to what? Okay, so go over your i's. You know I squared is negative 1. I cubed is negative I, and I to the fourth is 1. This is I to the fourth to the 10th with an I squared left over, because 4 times 10 is 40 plus 2 is 42. This is I to the fourth with an I squared left over. Now, if I to the fourth is 1, 1 to the 10th is still 1. So we can throw this away. And 1 to the fourth is still 1, so we can kind of throw it away too. I'm left with I squared, which is negative 1, and another I squared, which is negative 1, and their sum is negative 2. All right, moving forward. Number 10, solve secant squared equals negative secant squared minus 2 equals 0. So that would, if I add 2 to both sides, I'd have secant squared as 2. If I take the square root of both sides, I'd have it secant as plus or minus root 2. Now, I know, and you know, that secant is 1 over cosine. They are reciprocals. So if secant is equal to root 2, cosine is equal to 1 over root 2, which if I clean up, I get root 2 over 2. And don't forget about the plus or minus symbol, okay? So I'm asking myself, where on the unit circle is x equal to plus or minus root 2 over 2? And it's going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Super duper easy. Number 9, evaluate the tangent of the arc cosine of 3/5. The very first problem I did was kind of like this one, except it had an x in it. But this is asking, what is the tangent ratio of an angle whose cosine ratio is equal to 3/5? So, you know, the fuck you gonna do? You gotta draw a triangle. And you're just gonna put theta in the corner. Notice I always draw these a certain way. I'm actually forming a right angle with the x-axis. It's just the way you do it. Cosine has always been adjacent over. Ooh, this is negative. That's kind of a big deal. That is negative. Our cosine is in quadrants 1 and 2. I'm glad I caught that. So when I think about this triangle, my orientation needs to be changed, because I am actually sitting in quadrant 2. Cosine is adjacent over. Oh, I don't want you. Go away. How do I get rid of that thing? I get to this thing every once in a while. I don't know how to get rid of it. I don't know. Cosine's adjacent over hypotenuse. Back 3, 5. Now, the missing side's got to be a 4. It's a 3, 4, 5. And I want tangent. The tangent is opposite over adjacent. So the tangent is going to be negative 4/3. All right, evaluate the arc cosine. Is that it? There we go. Evaluate the arc cosine of the sine of pi over 4. So sine of pi over 4, 7 pi over 4 is going to be right here, okay? It's going to be the ordered pair root 2 over 2 and negative root 2 over 2. So this literally becomes the arc cosine. Since it's sine, I want that guy. It becomes the arc cosine of negative root 2 over 2. And again, I'm allowed to be in quadrants 1 or 2, and it's negative, okay? So this is a quadrant 2 angle. So in quadrant 2, when I see negative root 2 over 2 here for x, I know that I'm going to be at 3 pi over 4, or 135 degrees. We'll see how I write it. One of those two things. Now, I actually did this wrong on the last one, and I didn't even catch it until today. So I added a word here to remind myself not to miss it again. Determine the vertical and horizontal asymptotes and the whole for f of x equals x squared plus 6x plus 9. Sitting pretty over x squared minus 9 because it does have a whole. Now the top factors is x plus 3 times x minus 3. The bottom factors as x, that's x plus 3 times x plus 3. Let's just refresh that. The top is a perfect square, factors is x plus 3 twice. The bottom is a difference of 2 squares, it factors x minus 3 times x plus 3. Now, you can look at the bottom and you can say that x cannot be 3 or negative 3, but only one of those is a vertical asymptote. X equals negative 3 is the VA. The factor that cancels is the whole. So I think about x plus 3 being 0. X equals negative 3 is the whole in the graph. There's literally nothing there. There's your whole. Your horizontal asymptote is found through long division. Yeah, it's found through long division. And if you just multiply by 1, you get a 6x left over and you just stop. So y equals 1. And that was the bell for classes this morning, so I'm done, at least for now. Later.